What if every single window in this skyscraper was actually a silent, invisible power plant? We've officially moved beyond traditional solar panels. We're now harvesting raw heat directly from the glass surface itself. Using special materials, we are turning simple temperature differences into free electricity, effectively transforming the modern city skyline into a massive decentralized energy grid. This isn't science fiction. It's the future of how we power our world, and it's happening right now. Think about the windows in your home or office. You usually see them as a way to let light in, or maybe as a weak point for insulation, letting heat escape in the winter and creep in during the summer. But there is a hidden source of energy hitting your windows every day that you have been completely ignoring. It isn't just the light, it's the temperature difference trapped within the glass itself. We're talking about the massive, untapped potential of thermal gradients sitting right in your window frame. On a hot day, the outside of the glass is sizzling while the inside stays cool thanks to air conditioning. That difference in temperature is pure, raw energy just waiting to be harvested. For decades, we've focused on photovoltaics, the technology behind traditional solar panels. They're great at converting sunlight into electricity, but they have a blind spot. They don't capture the heat energy that radiates from urban surfaces, especially the vast expanses of glass on our buildings. This is where we need to shift our perspective. It's time to stop seeing windows as insulation liabilities and start seeing them as active solid-state batteries for our homes and cities. Energy's already there. We just needed a way to collect it. So how does it work? The science behind this is a fascinating phenomenon called the Seebeck effect. It's not new, but our ability to apply it on a transparent surface is a game changer. At the heart of this technology are incredibly thin films of a material called bismuth telluride. When one side of this material is hotter than the other, it creates an electrical voltage. It essentially encourages electrons to flow from the hot side to the cold side. Imagine the molecules on the hot, sun-drenched exterior of the window vibrating with energy. As that heat tries to move toward the cooler, climate-controlled interior, the bismuth telluride film captures that flow and turns it into a steady stream of electrical current. The beauty of this process is its simplicity. It's solid state, which means there are absolutely no moving parts, no turbines, no gears, no noise. This makes it incredibly reliable and virtually maintenance-free for its entire lifespan. We're not burning anything or using complex mechanical systems. We're just guiding a natural process, turning a simple pane of glass into a quiet, clean, and constant source of power. This is energy harvesting in its most elegant form. Now, you might be thinking, that's great, but I don't want my windows to be dark or cloudy. That's the challenge that stumped scientists for years. How do you generate power without blocking the view? The major breakthrough came in 2026 with the development of transparent conductive coatings. These coatings are the secret sauce. They allow the bismuth telluride to do its job without affecting the clarity of the glass. You can look right through it, just like a normal window, completely unaware that it's also generating electricity for the room you're in. This invisible power plant is woven directly into the fabric of the building itself. Let's compare this to traditional solar panels, especially in dense urban environments like New York or Tokyo. Rooftop space is limited and often overshadowed by taller buildings. But facades, the vertical faces of these skyscrapers, represent an enormous, untouched surface area. By harvesting heat instead of just light, thermoelectric windows can be incredibly efficient. On a hot summer day, the temperature difference across a window can be significant, providing a consistent power source right when demand for air conditioning is at its peak. This technology is tailor-made for the concrete and glass jungles we live in. The integration process is surprisingly straightforward. Standard double-pane glass, the kind used in most modern construction, is manufactured with this thermoelectric layer embedded inside. From the outside, it looks like any other window, but it's actually a high-tech energy scavenger. Let's scale this up and think about the impact. Imagine a single skyscraper in a city center. Each of its thousands of windows is now a small generator. When you add them all up, the building itself becomes a decentralized power station. It's generating a significant portion of its own electricity, right where it's needed. This has a profound effect on the urban electrical grid. During a heat wave, when everyone cranks up their air conditioners, the grid is pushed to its absolute limit, leading to brownouts and blackouts. But buildings with thermoelectric windows help to relieve that strain. They are producing the most power exactly when the grid needs the most help. This also brings about a fascinating economic shift. Suddenly, the building's facade isn't just a cost, it's an asset. It starts to pay for its own operational costs through this passive energy harvesting. Over the lifespan of the building, this can translate into millions of dollars in savings, making green technology not just an environmental choice, but a smart financial one. We're creating buildings that are not only shelters, but also active participants in our energy infrastructure. This technology is a glimpse into the future of autonomous architecture and smart cities. We're heading toward a world where every surface has the potential to contribute to a self-sustaining energy ecosystem. Imagine roads that capture heat from the sun, walls that generate power from temperature differences, and of course, windows that silently power our lives. The global impact on our carbon footprint would be monumental, and every building helps regulate and power its own environment. Our reliance on centralized fossil fuel burning power plants diminishes dramatically. We are at the beginning of an era where the distinction between building materials and power generators completely disappears. Architecture will no longer be static. It will be dynamic and alive, interacting with the environment to create a sustainable and resilient future for all of us. This is more than just a new type of solar panel. It's a fundamental change in how we think about the cities we build and the energy we consume. Thank you so much for joining me on this look into the future of energy. If you found this fascinating, make sure to like this video and subscribe for more content about the technologies that are shaping our world. Let me know in the comments what you think about thermoelectric windows. See you in the next one.